In this video, we're going to talk about function notation with equations. So by the end of the video, we should be able to evaluate and solve equations that are written in function notation. And so what that means, to look at an example, is if you were given f of x minus 3 equals negative 3x plus 5, we should be able to evaluate when f of 0. Okay, so let's take a step back from that. We have this new symbol, f of x, and the way we say that is literally f of x. And this is going to be our new version of y. So sometimes we say f of x equals y. So before, what we might have seen when we see an equation, just as an example, we would have y equals negative 3x plus 10. All right, now with function notation, we have f of x equals negative 3x plus 10. Right, those two things mean the exact same thing. The only thing that's different here is that we've replaced y with f of x. Otherwise, mean the same thing. Okay, so before we might have been asked to find y if x equals 1. Right, so that we're familiar with, right? We're just going to plug in or substitute this 1 in place of the x. So let's do that. Y equals negative 3 times 1 plus 10. And now we're just going to simplify. So y equals negative 3 plus 10. Negative 3 plus 10 is 7. So y equals 7. So we're saying that when x equals 1, y equals 7. In other words, when the input is 1, the output is 7. We can ask the same thing using function notation. We just write it a little differently. So we would say this exact same thing by writing evaluate f of 1. And what that means, this notation or this way of writing means that x is 1, figure out what the output's going to be. So we're going to write f of 1 equals negative 3 times 1 plus 10. Notice the exact same thing is what we had with y, but now we just have f of 1. We're specifying the input. All right, and using this, so we're just going to continue to evaluate in the same way. So f of 1 equals negative 3 plus 10. And when I add negative 3 and 10, I get 7. So f of 1 equals 7. And again, that's saying that when the input is 1, the output is 7. Let's take a look at another example. So I have a new function here, g of x equals 4 times x minus 1. So we want to be careful. Usually when we see parentheses, we think multiplication, but g of x is actually one whole thing there. We're going to keep it all together always. So this is g of x, whereas these parentheses, this says 4 times x minus 1. And there's a couple things we can do. So like before, let's solve for the output when we're given the input. So that would look like evaluate g of negative 2. First thing I have to do is figure out what is this telling me. This says that x is negative 2. So what I can do is say that g of negative 2 equals 4 times negative 2 minus 1. All I did was replace the x in my original equation with negative 2. So g of negative 2. I'm going to go ahead and keep solving. Negative 2 minus 1 is negative 3. And 4 times negative 3 is negative 12. And that's it. That's another way of saying that when x is negative 2, y is negative 12. Or when the input is negative 2, the output is negative 12. Okay, so another thing you might see is that you need to solve for x. Okay, so that would look like this. Solve for x when g of x equals 32. Okay, so we don't know what x is yet, but we do know that the output, or what we used to call y, is 32. Okay, so I'm taking this whole g of x. Let's rewrite the equation just to help clarify. So I'm taking this entire g of x, because that represents the output, and I'm replacing that entire thing with 32. Everything else in the equation stays the same. And now I need to solve like normal for x. So I might decide to distribute here. So 4x minus 4, and then add 4 to both sides. I get 36 equals 4x, and divide both sides by 4. And we get 9 equals x. And there we go. So if we're given that the output is 32, we can find that the input must have been 9. All right, so try it on your own now. We said at the beginning, if you can solve f of x minus 3 equals negative 3x plus 5, go ahead and evaluate f of 0. So pause the video, try that on your own, and compare your answer when you're done. All right, and I have all my work shown. I ended up with f of 0 equals 8. We threw in kind of one little trick in there, is that we're actually solving for f of 0, so we will have to end up adding 3 to both sides of the equation in order to get f of 0 equals 8.